Here is another question, and just to show you, we have two operational amplifier. Okay, so we need to get the transfer function, and then we know this one is gonna be our Z1. Okay, this one is gonna be our Z2. We're just gonna go with the same principle. This one is gonna be our Z3 with the same principle, and this one's gonna be our Z4. Okay, so now what we're going to do, we're going to try to solve it. Okay, so we're going to divide it into two. Okay, so we're not gonna solve it in one block. We're going to have branch 1 and branch 2. Okay, so we're going to solve it separately. So this is actually branch 1, and this one is branch 2. Okay, so what we're going to do here, we're gonna break it down into two blocks. Okay, so just to make it easier for us, so then we can solve it. So what I'm gonna do here, straight lines, so we can have two equal space when we can solve it. Okay, so we're gonna take this this part. Okay, let me just take this part until Z2. Okay, good. Now in this side, we're going to take from Z2 all the way to Z3. Sorry, V3. So from V2. Okay, so now we have something like this. Okay, so we're going to see how we can go about solving this question in this way. So we have now two blocks, so this way, this time we'll be able to solve it. Okay, so let's go right inside these two question. So now we need to get both transfer functions. Okay, so for this one, I'm going just to write the transfer function as J1 is equal to, so let me just write it correctly, J1 is equal to V2 as V1 is, okay, which is equal, since we have a negative sign here and also this side, that's why we're going to write a negative sign there, and then Z2 is over Z1 is, that you see there. And the same goes for this other block, branch 2. For the transfer function, so it's gonna be V3, the V3 over V2, which is equal to negative Z4 S over Z3 S. So the transfer function will be the output over the input. Okay, so that's what we're gonna get there, and we're going to break it down and solve them separately. Okay, so what we're going to do here, since we got this, we're going just to break it down again. Okay, I think I was supposed to use this cable. Okay, let's break it down again. We're going to separate them, and we know Z1. This is we're going to solve for Z1. Okay, and we know we're going to come with the resistor R1. Okay, you come out like this, and we know already this is Z1. So we know already this is Z1. So Z1S will be equal to R1. Okay, remember we're not gonna consider the current. I can even, let me just write down the current there, but which we're going to simplify. We're going to remove it in all the equation we're gonna get. We're going to remove the current, so we're going just to stay with only what is inside. So since all the current, we're going to cancel it out. So the same goes for R3. So R3. Okay, and we know all of this, it's Z3. So we're going to say Z3 S will be equal to the current times R3. So since we're going to cancel out the current in all, so we're going to remain only with R3. Okay, let's now go and attack another block. Okay, so for another block, we remember that for Z2, okay, we add a resistor, and then a capacitor, this is C1, and for this block, for Z4, we got C2. Okay, and remember that we call this one as this one. So this one is Z2, and this one is Z4. We're going to write the equation here that we're gonna get. So Z2 will be equal to, in terms of S, will be equal to R2 parallel. So R2 parallel what? 1 over CS. Okay, meaning it's gonna be the voltage R2 in parallel the voltage VC1. That's what you see here. Okay, and then since we're not gonna represent the current, if we have to show the current so that we can cancel it out, so you can see. So we're going to have okay, so I'm going just to present the current and then let's cancel it out. So we're gonna have the current that is actually multiplied to both, and then when you cancel out the current, so you're going to have this one in parallel with 1. Okay, so let's go with this this one, so then you can see Z4 will be equal to 1 C2 S, meaning we're going to have VC2 And since, like I said, we're going to cancel out the current, I'm going to show the step where we got that current. It's gonna be I is, so that's what we're gonna get there, and then cancel out the current. So when you're going to cancel out the current, so you're going to remain only with Z4 is equal to 1 C2 is. Okay, so this is what we're gonna get. So now we have all of this, we'll be able to solve this question. Okay, after gathering all of this, there is one thing that we need to do first. We need to get the parallel equation. Okay, once we get that parallel equation, we'll be able to solve the question. Okay, and also get a transfer function. Remember, we already mentioned them on top there. So what I'm going to do here, I'm going to explain how we're going to get the transfer function, how we're going to place them into the transfer function. Okay, and then okay, so I'm going just to write it correctly. So for the transfer function one that you see here, we're going to have something like this. We know that we add Z2 S over Z1 S, which is equal to negative Z2. Z2, it's what you see here. So, and we did mention, so I'm going just to write it in this side, so then we were able to see it. So now what will be J1 and J2? Okay, so J1 of S will be equal to that's equation there, it will be negative Z2 S over Z1 S, which is gonna be negative Z2 S times 1 over Z1 S. Okay, so what do you do after this? We need now to plug the value back inside the, okay, and we know that it's gonna be negative, what is Z2? Z2, it's actually R parallel 1 CS times Z1, it's gonna be R1, which is going we can also write it in this way. It's gonna be R1 negative R2 parallel 1 over C1 S. Okay, so if you have to go for J, for another one, so let's go maybe for J2. J2 is gonna be, it's gonna be negative, the formula that we use there, Z4 S over Z3. That's the formula that we have highlighted. So it's gonna be negative Z4 S times 1 over Z3 S. And if you have to write it correctly, it's gonna be negative, what is Z4? Z4 is 1 over C2 S times, what is Z3? So Z3 is gonna be R3. Okay, so this is what you get for from J2. And once you're done with that, you can also swap around, so then you can solve for V3 over V1, so then you can get the answer for V2 over V1. And the way to do that is you need to remember that we've mentioned here. So let me just take those formulas. Okay, so we have said that J1 equal to V2 over V1 S, and also this side we said that J2 is equal to V3 over V2 S. And then if you have to work it out, it's gonna be V2 S will be equal to J1 S times V1 S. The same goes for this one. J2 times V2 S will be equal to V3 S. That's what you see. We're going to move this fraction on that side, and also times this fraction, and we're going to assume that we have 1 at the bottom. Okay, and once you get this, you'll be able to swap, okay, and solve for V3 if you want to. So in short, you're gonna get those two equations, and then you can now work the transfer functions. Okay, so what I'm going to do, I'm going to just write them here so then you can see how we can proceed from there. And these are the equations that we got. So it was V3S equal V2 S J2 S, and then V3 S equal to V1 S J1 S J2 S. Okay, so this is what you can get from this equation if you're just starting to replace. Okay, and what we did here, we just replaced the value of V2. Remember, we got V2. What is V2? And our V2, it was this equation here. So we have this equation and this other equation at the beginning. So it was V2 S equal to J1 S V1 S. So we just replace this value, this equation, into that V2S. So that's why we got what you see at the bottom, and from there we were able to determine to solve for V out over V1, which is gonna be, if you have to consider this equation, it's gonna be V3 over V1 as it will be equal to J1 S times J2 S. Okay, that's what you see there. And if you want to write this correctly, okay, it's gonna be something like this. Okay, I'm gonna create some room for me to work some space. So it's gonna be, I'm going to replace the value of j and then the value of so it's gonna be something like this: negative z2 s z1 s. This is what you're gonna get from j1, and then from j2 it's gonna be negative 4 s over z3 s. So this is what you're gonna get here, and then you'll be able to get a transfer function by solving those equations. And for j1, so this is j1, and for j2 this is j2. Okay, you're going just to plug the what we get, and then you plug it there. Okay, so it's gonna be this one for j1 and this one for j2. You're going to plug j2 here and j1 there, and then you work out, then you'll be able to get your transfer function. So the transfer function from vi, v1 and v3. So the question was to solve for v3 over v1, which was a transfer function of this system. So it's the output, the final output over the first input. Okay, so that's what you see there. So, and we had to do all of this in order to solve it, and in the final, this one times this one. So for us to get the transfer function, okay, so and the answer is was for j1 times j2 to get the transfer function. So it's actually this one here. Then we can just plug the value and solve, and then you'll be able to get your final answer to that question.